Hi friends, now we will discuss on the topic petroleum as a source of energy. So, in the previous classes we have seen that after coal the petroleum is mostly used as energy resource around the world, and this is also a fossil fuel. And now we will see what is petroleum, what is the composition of it, and what is the heating value of it, and what are the different forms of energy we can get from it, and what are the issues or types of it, etc. So, now the contents are here. What is petroleum, origin of petroleum, availability of petroleum and energy production from it, types or grades of petroleum, and petroleum products, its characterization, its classification and energy content, composition of crude oil, pricing of petroleum, and petroleum for energy production, some issues. So, these are the contents of today's discussion. Now, let us see what is petroleum. So, as the word says petroleum, it is derived from the petra and oleum. So, petra means rock and oleum is oil. So, literally it means that rock oil, and it is defined as a, it is basically a mix of naturally occurring organic compounds from within the earth that contain primarily hydrogen, carbon and oxygen. So, petroleum and crude oil, these two terms are used widely, and apparently both are similar and very different, are used for the same purpose, but the crude oil is a complex mixture of hydrocarbons, different types of hydrocarbons, paraffins, naphthenes and aromatics, and brownish black in color and colloid in nature. Petroleum is also similar, same. The only difference is that petroleum is a broad category that include both crude oil as well as the petroleum products. And if we see the elemental composition of these, it contains carbon, hydrogen, nitrogen, oxygen, sulfur and metals. So, mostly carbon, then hydrogen, but here hydrogen is more with respect to coal, and heating value is also higher in case of this. Now, we will see the origin of petroleum, how the petroleum was originated. In case of coal, we have seen that there are different thoughts who explain the formation of coal under the earth's crust. Here also there are different thoughts. Here some thought says that it is originated from animal sources, and some thought says that it is from inorganic sources. So, one is inorganic and organic theory. Unlike coal, this is suppose that petroleum is originated from animal sources, but coal was from plant sources as per this organic theory. Now, if we see the inorganic theory, then this theory says that carbon and hydrogen came together under high pressure and temperature below the earth's surface and formed oil and gas where chemical reactions took place. Organic theory says that the most that the substantial conditions for the formation of petroleum, such as saturated soil, absence of oxygen and high pressure and temperature conditions, under this condition the decay of organic matters transformed into kerosene, forming source rock. So, that is the source of the petroleum, and it is assumed that the animal bodies are converted to this petroleum. Now, what is the availability of petroleum and energy production from it? If we see the total world oil reserves, then we get conventional oil 30%, heavy oil 15%, extra heavy 25% and oil sand is 30%. So, these are the different parts or the type of petroleum resources, and worldwide reserve by region wise you see Middle East have around 49%, then America, North America 13% and Central and South America 20%, then Africa is only 8% and Eurasia is 7%, but we Asia has very less reserve. We also have some reserve, but very limited. Now, if we see the world energy used by fuel, then Asia Pacific region, North America, Europe, Russia, Middle East, South Central America and Africa, we see here the oil is used everywhere in significant amount after coal. And the prediction says that we are here at say somewhere, so the prediction says that the world liquid oil and gas depletion as predicted in 2004, that in future the amount will be reduced, the availability of this oil may be reduced in near future. Now, we will see the types and grades of petroleum. So, petroleum can be divided into different grades depending upon the degree API, that is the specific gravity. So, light crude, heavy crude and medium crude oil. So, light crude means its degree API is higher, more than 31.1 API, and heavy is dense oil. So, it is having API below 22.3. So, in between these two 22.3 to 31.1, this is called medium oil. So, this is one way of classifications of the oil that is light, medium and heavy oil. So, if we see the availability of the oil petroleum crude around the world, we can get three major locations. The one is your West Texas Intermediate in America, another is your Brent blend, that is also located in the North Sea, and then OPEC reference basket, that is in Algeria, Iraq, Kuwait, Libya, Qatar, Iran, Saudi Arabia, Indonesia, Nigeria, Venezuela and UAE. If we say this crude oil is relatively of lower quality, degree API is 32.7, whereas here we will get the highest quality 39.6 degree API and sulfur is also 0.24%, and this is medium, that is 38.3 lesser than 39.6 and sulfur is also higher than this 0.37, and here the sulfur is higher and this API gravity is also lower. So, in terms of these three, this is of inferior quality crude oil. Now, what we will see, different crude oil will give us different yield. So, you see some example, Bombay High, Bonny Light and Arab Light and Kuwait. So, these different sources crude oil if we take and if we want to refine it, we will not get the similar type of products. In India you see the Bombay High crude, we are having very high amount of middle and light distillates also, but heavy ends are also relatively less in this case. So, the quality of the oil available in India in Bombay High, it is good, but reserve is less. But here you see Kuwait, the heavy end is very higher amount, then middle distillate and then light distillate. So, the origin of the petroleum will also can generate or can give different type of liquids after its refining, or we need different types of technology to process these different type of feedstocks to get certain amount of liquid product. So, this slide gives us some comparison of Middle East crude quality, that is Arab mix, Iran light, Iran heavy and Kuwait and Bahrain. So, these are the properties like say gravity, pour point, wax content, asphaltene, total sulfur and yields, light distillates, middle distillates and residue, it is given. So, one thing it is clear that here it is having less residue, higher the API, lesser the residue, obviously because it is lighter. So, residual part will be less. Then what are the different liquid we can get or different energy we can get from this, different form of liquids which can be used for energy source from the petroleum crude, that we want to discuss now. So, crude will be refined first and different fractions we will get. So, here we are getting the crude, it is heated, preheated and it is fractionated in this column. After fractionations we get different products as shown here, C1 to C4 gases, we will get LPG here to 20 degree centigrade, and then here say C5 to C9 naphtha we will get 70 degree centigrade, and C5 to C10 petrol or gasoline we can get at 120 degree centigrade. C10 to C16 we can get kerosene at 170 degree centigrade, and C4 to C20 we can get diesel oil, that is equal to 270 degree centigrade, and C20 to C50 that is lubricating oil, and then C20 to C70 fuel oil, and then the residual. So, these are the different fractions we can get from the crude oil, and those fractions can be used in different applications like say LPG as a heat source, and then naphtha is very important. Once naphtha can be converted to different types of chemicals, that petrochemicals. So, we can get petrochemicals from naphtha, and as you know that diesel, petrol, all those things are used to run the vehicles, and ATF, aviation turbine fuel, is also used, that is the jet fuel, that is a kerosene and ATF are having very similar properties, and others are fuels, that is lubricating oil is also used for the lubrications of machines. And residual part, this is one issue that can create lot of pollution, and we have a scope to improve the quality of residue, so that we can reduce the loss and we can improve the economy of the process also. So, now we will see the different refined products. So, gasoline, diesel and jet fuel, these are the major products which are produced through the refining of petroleum crude and used in different types of transport, and other secondary products are kerosene, LPG, fuel oil, asphalt, carbon black, lubricating oil, waxes, petroleum coke and those things, and sulfur if you can recover, then that can be used for chemical synthesis, and NaHS that is used can be paper, copper mining and leather industries. So, these are the different refined products which you can get from petroleum refinery, and that can be used for different applications. So, one way it is giving us energy, other way it is also giving us different types of petrochemicals. Now, we see the heating value of the different products which we can get from the petroleum crude refining. So, LPG, gasoline, kerosene, diesel and residue, heating value is this much for LPG 46.1 megajoule per kg, then gasoline 46.5 megajoule per kg, kerosene 46.2 megajoule per kg, diesel 45.8 megajoule per kg and residue 42.2 megajoule per kg. But in this case what we have discussed in the previous slide also, that there is a specific temperature it is mentioned, but we have some flexibility to vary this temperature and to maintain the control the quality of the products also. Then different petroleum products which we get, that we have different boiling points we have discussed, and that boiling point largely determines the size of the molecules and what type of product we will get more. and overlap in boiling ranges provides flexibility in production, just we have discussed. And you see LPG, gasoline, kerosene, diesel, light gas oil, heavy gas oil and residuum. So, this is the temperature at which we can get, these are the temperature we can get different types of product. Now, we will see what are the composition of a petroleum crude or petroleum. So, petroleum crude oil, if we see, that is hydrocarbons basically. So, it will be mostly hydrocarbons and non hydrocarbons are also present, those are called impurities. So, hydrocarbons may be aliphatic, naphthenic, naphthenes and aromatics. So, these three types of hydrocarbons basically present in crude oil, and non hydrocarbons are like sulfurs, nitrogens, oxygens and metallics. These are basically present in it, and typical range is given, say 25% asphaltic, 17% aromatics, 50% naphthenes, and naphthenes is very important. It is used for the production of different types of chemicals, naphtha, and then sulfur is this one, nitrogen is less and oxygen is also less and metals is also very less than 1000 ppm. And these are the molecular structure of these different types of compounds which is present in it, or hydrocarbons present in it. This is aromatic ring, it has, and it has some naphthenic rings, naphthenes. So, aliphatic and the paraffin are basically present in the crude oil, and then isoparaffinic compounds are also present in large amount. So, paraffinic and isoparaffinic both are present in asphaltics. Now, we will see some example of this. So, paraffins, that is propane, N-butane, N-hexane, N-heptane, N-octane, N-nonane, N-decane, N-undecane, N-dodecane, N-tridecane. So, this is C2 to C13, some boiling range are given here. So, obviously, the higher the carbon number, more will be the boiling range. So, up to C3, C4 basically we get it in LPG. Now, the paraffins which are available in petroleum crude, basically they are having say CnH2n plus 2 formula, CnH2n plus 2. So, and the compounds which are higher carbon, which are having higher carbon, that is C16 and 34, they are mostly in solid form, and in some cases we get mostly we get C40 to C40H82, and in some cases we can get C100 even, mostly up to C80 we get, in some cases we can get more than that, that is C100. And these paraffins are low in heavy graded oils, that is up to 35% in light crudes, and sulfonated these paraffins can be used for biodegradable detergents production, and oxidation of C8 and C30 in paraffins result fatty acids and soap industries, and oxidation of C12 to C14 normal paraffins result secondary alcohols, and this paraffin wax which is available higher carbon number of paraffins, they contribute on freezing point of ATF, aviation turbine fuel, cold flow properties of diesel and lubes, and ignition quality of gasoline and diesel. And the isoparaffins which are available in this, the general formula is CnH2n plus 2, and C4 to C33 have been isolated in petroleum in higher extent, and predominant form is here the iso CH3 chain as a side chain is available in most of the cases, and highest concentration of 2-methyl alkanes in C6 to C8 range it is available, and di and tri substituted are less abundant and are mainly present in higher boiling fraction, and most desirable components for the gasoline this one, these isoparaffins are desirable for gasoline, ATF and lubricating oil, and these are the if we have highly branched isomers, then this is not undesirable. The naphthalene is CnH2n plus 2 minus 2 Rn. Say this is one naphthalene. So, how many, this is C, 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 C. So, how many moles? Num 1, 2, 3, 4, 5, 6, 7, 8. So, 8 n equal to 8. So, H we are having 2H, 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 again 2H, again here we will have 2H and 2H, and here 1H and 1H. So, these 2 Rn, Rn means 1 and 2, 1 and 2, we have 2 rings, 2 rings. So, Rn is the number of naphthenic ring in this case. If this one, so you have 1 ring, so Rn equal to 1. So, this is the general formula. So, here in this case n equal to 8. So, that will be 8 plus C8 H 2 into 8 plus 2 minus 2 into 2. So, this is the formula of this naphthenic compound. Now, in crude oil, naphthenics are present about 50% by weight, and its quantity is higher in heavier fractions. Heavier the crude, more the naphthenic compounds. And if naphthalene are present, then what will happen? They will give us more naphtha and lubricating oil, and these are stable hydrocarbon, and cyclopentane, cyclohexanes and their alkylated derivatives are normally found. Then aromatic hydrocarbons, means some benzene ring will be available, or more number of rings may be available in this case. So, general formula is CnH 2n minus 6 or C2NH 2n minus 12. So, this is the formula, and these are already 15% of weight in crude oil it is, and more the this aromatic present in it. So, what will be happen in this case, octane number will be boosted. So, for gasoline it will be favorable. So, the octane number of aromatic hydrocarbon is much higher than the paraffins and isoparaffins, and these are chemically reactive and can form both addition or substitution products, and high amounts of polycyclic aromatics are present in heavy gas oil, lubricating oil and in residues. Now, we will see main constituents of crude oil. So, obviously carbon and hydrogen, this is the main constituent, and different fractions of this LPG, gasoline, gas oil, VGO and residue. If we see basically the LPG paraffins, then gasoline, paraffins, aromatics and naphthenes, kerosene also same, and the residue is mostly asphaltic and their carbon range is given here. These are the typical range. Now, how will price the crude, how the crude oil is priced, what is the cost is decided on which basis? Obviously, it will be on its quality, and degree API and sulfur content both are considered for its pricing. In case of coal, we have discussed that ash content and moisture content was also considered. So, in this case we have our sulfur and API, these are used to fix the price, and then high sulfur heavy crude is obviously low cost. If you see, if we increase this, if we go that way, so degree API is increasing, the quality is improved, the light it is becoming lighter and lighter, and then sulfur content. So, sulfur content is also reducing. So, cost is higher cost, low sulfur and high API. This is the basis, the price is fixed. But how the price will be fixed? There are benchmark, some benchmark. One benchmark is your West Texas Intermediate WTI, and then this is also called as Texas light sweet, another is Brent crude and another is OPEC reference basket. So, India we mostly dependent on OPEC reference basket, and the price is dependent on many factors. What will be the crude price today, tomorrow it may change. So, that will be influenced by many factors. Those are supply and demand fundamentals, then we have OPEC policies, the organizations of the petroleum exporting countries, they have the members of this Iran, Iraq, Kuwait, Saudi Arabia, etc. So, these countries they have their policy, and political issues also influence it, the political and economic developments in the exporting and consuming countries. So, what is the relationship between India and Iran or Iraq or Kuwait. So, that will also influence the price of the crude, and weather conditions, because how it will be transported and what is the weather conditions, that will also influence the crude price. Then petroleum for energy production, some issues, we will be discussing some issues now. So, oil based economy and carbon credit, that is one issue. Our society is mostly dependent on oil utilization, and it produces carbon dioxide. So, if we use more oil, so we will be producing more carbon dioxide. So, carbon credit will be in consideration. So, that is one issue. So, we have to optimize the things that carbon emission will be reduced, and depletion of high quality crude oil. The high quality crude oil is being reduced, as we have seen in one slide, that it is projected that the supply of crude oil will be reduced, and even the quality is also degraded day by day. So, lower the quality, more the SOx emission and more the ash emission. So, industrial emissions will be more with the degradation of the quality of the crude oil, and sustainability issues. In 21st century, sustainability is an issue where we have to ensure the energy supply, we have to environmental quality and social equity. So, under this situation, if we see the carbon emissions from liquid fuels, so here we have million tons CO2 release. So, total this much. So, here 2020 say 36,834 million tons of CO2 is expected to come from different types of fuels, and liquid fuel from it is expected to come 13,582 million tons of CO2. So, around 1/3 of the total CO2 is coming from the liquid fuel. So, this is one concern, that how to control the carbon dioxide emission from this fuel if we want to use more effectively these feedstocks for energy resource. And then another target is that as per Kyoto Protocol, we have to reduce the carbon dioxide emission level in 1997, which we had, and now 2020 we had some target that 10% will be reduced, the carbon dioxide emission will be reduced, and 2020 it is targeted to reduce by 20%. So, we are under pressure, we have to reduce the carbon dioxide emission from all source of energy and other activities, and this liquid fuel contributes on carbon dioxide emission. So, we have to take actions, we have to develop cleaner technologies for its proper applications. So, up to this in this class, thank you very much for your patience.